Hey everyone, this will be your first of 3 videos that I'm going to post today, which are answer key videos for doing the review problems. I just want you to have these while I might not be here for 6th hour, and 3rd hour you can use them too. Nothing wrong with that. So here we go. Number 1, divide both sides by 3. 3 to the negative 10x equals 20 log base 3 of 20 equals negative 10x. Divide both sides by negative 10. And I get x equals log base 3 of 20, all divided by negative 10. In the calculator, that is negative 0.27 287. There we go. Okay, number 2, add 3. Divide both sides by 7. Should be negative, sorry. That doesn't reduce, so I'm going to keep it. Oops, this should be positive now. My fault. Okay, equals negative 4x plus 9. Subtract 9, divide both sides by 4. I get x equals 1.9542. All right, number 3. Divide both sides by 10 first. I get log base 7 of x plus 6 equals 4. So 7 to the 4th is equal to x plus 6. So x equals 7 to the 4th minus 6, which is 2395. Number 4. Logs are both base 10, so I can rewrite 6p plus 3 equals p squared plus 8. This is just a quadratic. I'm going to move everything over to the right side. I get 0 equals p squared minus 6p plus 5. This factors as p minus 5 times p minus 1. So I get p equals 5 and p equals 1. They should both work because they're both positive. They're going to give you a defined value on both sides. So that'll work. Number 5. In this moment, I would subtract 8 first. I'd get 24 on this side. And so then I divide both sides by 4. I get 8 to the r equals 6. So log base 8 of 6 equals r. And so I get r equals 0.8617. Okay, number 6. This one just straight up converting to logs. Log base 13 of 79 equals 10 minus 3n. Subtract 10, divide both sides by negative 3. I get n equals 2.7655. All right, there's the first page. Second page, log properties on this page more often. So log base 5, we have to combine this into x plus 23 times x plus 3. There's kind of these like also outside parentheses on that whole thing, equals 3. The inside's going to FOIL as x squared plus 26x plus 69. So then I get 5 to the 3rd equals that quadratic. Um, 5 to the 3rd is 125. Same thing. So I get to subtract that over. And that gives me, I'll just kind of sneak it in here, 0 equals x squared plus 26x minus 56. And this is going to factor as x minus 2x plus 28. So I get x equals 2 and x equals negative 28. Negative 28 is going to be extraneous because both places, if I put it here and here, I'm going to get a negative number inside the log, and we know the domain of logs is positive. So that's not going to work. The 2 should work, so I'm going to exclude this one and circle this one. Again, number 8, we have to apply some log properties here. I would start by combining the logs as log base 3 of x minus 6 over x, all equal to 3. So then that means that we've got 3 to the third equals x minus 6 all over x. So I've got 27x equals x minus 6. So I got 26x equals negative 6, so I get x equals negative 3/13, which is extraneous because if I put it there, it's undefined. So this one doesn't work, so we have no solution here. Next one. This is one of the ones that we talked about in class, but it's a little tricky because we have to convert these numbers into powers before we can start doing them. 243 is 3 to the 5th. 9 is 3 squared. And then 181st is 3 to the negative 4th. And so when you're working with this, you keep the original exponents. Now we have exponents to exponents, and the rule for combining those is to multiply. So I get 3 to the 5n plus 5 times 3 to the negative 4n minus 4 equals 3 to the negative 4. Now I have these two that can be combined by adding the exponents because they're like bases. So I get 3 to the 5n minus 4n is 1n, and then 5 minus 4 is 1. So I get n plus 1 equals 3 to the negative 4. And so I can conclude that n plus 1 is equal to negative 4 because otherwise, I mean, how else couldn't it be? But these exponents have to be the same. So then I just get n equals negative 5. We should check our work at the beginning. It should work just fine. Number 10 is a little tricky. Same idea. A couple of people had some different ideas about this one. I like the idea of multiplying everything by 25 to the r minus 2 first, so that we have a problem that's very similar to the last one. That's going to give us 625 equals 125 to the negative 3r. 25 times 25 to the r minus 2. 625 is 5 to the 4th. 125 is 5 to the 3rd. And then 25 is 5 squared. So then we can apply those same rules as we just did on the last problem. We get 5 to the 4th equals 5 to the negative 9r times 5 to the 2r minus 4. And then we can combine those by adding those exponents right here. So we get 5 to the negative 7r minus 4 equals 4. Sorry, 5 to the 4th. And so then we can conclude that 4 equals negative 7r minus 4. And we'll end up with r equals 8/7 here. Negative 8/7. That one should work just fine as well. Number 11 is again one of those ones where I can do the division. So I end up with log base 9 of x over x plus 5 equals 1. So 9 to the 1 is equal to x over x plus 5. And so I get 9x plus 45 equals x minus 9 minus x minus 9x. I get 45 equals negative 8x, and so x equals negative 45/8, which again, if you put it in here, you're going to get an error because can't put negatives into logs, so that's extraneous, so there's no solution here. Next one, oh, this one's a natural log, look at that. Same rules though, ln 8 times x squared minus 2. You can combine those two logs by multiplying the stuff inside. Equals 4. I get e to the 4th is equal to 8x squared minus 16. I definitely can solve for x sort of normal here. Add 16. I get 8x squared equals e to the 4th plus 16. divide both sides by 8. This is where you can kind of write it a couple of different ways, but I'm going to go with this. I get x squared equals e to the fourth plus 16 all over 8, and then take the two square roots. I get x equals plus or minus the square root of e to the fourth plus 16 all over 8. Both of those are going to work just fine because when you put in the -1 here, it still becomes positive when you square it. So everything's positive anyway. This one is really quick because you can just conclude that the two things in the exponents are equal. So we say 3n equals -3n. The only value for n that works for that is 0. And so that's the answer. If you want the proof, you can add 3n to both sides and divide both sides by 6. This one, divide both sides by -9 first. I get log base 8 of b to minus 9, 8, excuse me, is equal to 3. So 8 to the third is equal to b minus 8. So then I just have to add 8 to both sides, so I get b equals 520. There's a second page. See you for the next one.